Yes, my students, how are you? You are quite well? Okay. Today we are going to take a new topic, gravitation, distinguish between mass and weight. Now see here, we are going to make the distinguish between mass and weight. As we are going to make the distinguish between mass and weight, we are dividing it into two parts. Now here on one side it is mass, that is here it is weight. Now the first difference, that is the definition of mass. Definition, it is the amount of matter present in an object. Okay, it is the amount of matter present in an object. And here first it is a force by which earth attract any object. Okay, it is a force by which earth attract any object towards it. Object towards okay. It is a force by which earth attract any object towards it. Now the second one here, it is a scalar quantity. And here the second point is, it is a vector quantity. Now see here, it is a scalar quantity. You know that scalar quantity can be represented by only by magnitude or by number. And here the vector quantity, it requires magnitude and also direction. Here the third point, it remains constant. It remains constant everywhere. Here it varies from one place to another. Now see here, it remains constant. Whatever is the mass on the earth, if you will take it to the moon, its mass will remain. Means its matter will not change. But what happens? This weight varies from one place to another. That is, if the weight of an object on the earth is 36, then its weight on the moon will be 6, because weight is equal to mg, and acceleration due to gravity, that of moon is 1/6 of that on the earth. Okay, now the fourth point, SI unit of mass is kilogram. And the SI unit of weight is Newton. Now see here, when we are going to take sugar or something, we are getting in kilograms, we are not getting in Newton. It means that we are taking mass, we are not taking weight. Understood? This is the distinguish between mass and weight. The next topic as here is free fall. Now we are going to take the topic here, free fall. Free fall. Okay. Now the definition of free fall. Here if an object is falling only under the influence of earth gravitational force, it is called free fall. Now see here, if an object is falling only under the influence of earth gravitational force, it is called free fall. But now see, if we are going to release an object from upward, then there are two more forces applied, that is the frictional force frictional force of air and the buoyant force of air. Okay? Buoyant force of air. These two forces are automatically applied on the object. Okay? Therefore, free fall can occur only. Free fall can occur only in vacuum. Means free fall can occur only in vacuum. Now see here, during the free fall, the initial velocity of the object is 0 and its acceleration a is equal to g. Therefore, we can write the three equation of motion. Now see here, for free fall, the initial velocity u is equal to 0 and acceleration a is equal to g. Therefore, the three equation of motion, therefore the three equation of motion can be written as below. Now see here, the first equation of motion is V is equal to U plus AT, and for that, as I told you, U is equal to 0 initial velocity and A is equal to G. By substituting the value, V is equal to 0 plus GT, that is V is equal to GT. This is the first equation of motion for the free fall. Similarly, the second equation of motion, that is S is equal to ut plus of AT square. Again we are going to write U is equal to 0 and A is equal to G. What will happen? S 0 into T plus of G T square. Therefore, S is equal to of G T square. This is the second equation of motion for freely falling body. Now the next, the third equation of motion, V square is equal to E square plus 2AS. Here also we are going to write U is equal to 0, A is equal to G. Therefore, V square is equal to 0 square plus 2 GS. It means V square is equal to 2GS. This is the third equation of motion for the freely falling body. Okay, understood?